Hey, Algebra 2, here we are at the end of CFR3 and CFR4, describing and graphing transformations of functions. Here we go. Let's go ahead and get this started on the last check. Describe the transformations, that's our CFR3, then sketch them using the table. What do I got going on in here? I have a reflection over the x-axis because it's vertical. I have a vertical compression because it's between 0 and 1. On the inside, because we're on the inside, it's horizontal. This is a horizontal compression. And here, this goes right 3 units. All right, my parent function in here, I noticed this squared. So my parent function is x squared. We're going to use that information down here in CFR4. X squared. My critical values, if you don't remember where I'm getting these from, it's because you probably need to look at the parent function packet. Parent function packet. Critical x values, -2, -1, 0, 1, and 2. Critical y values that go along with that, the squareds are 4, 1, 0, 1, 4. Put the vertical things in, multiplying by -½. And then my translation is +0, because there's nothing adding, subtracting at the end. In here, horizontal stretch, compression, reflection, y-axis. In this case, it's just 2. And then this says x -3. Remember, for horizontal, we do the inverse operation. So instead of multiplying by 2, we're actually going to divide by 2. Instead of subtracting 3, we're actually going to add 3. When we do that, -2 divided by 2, that's -1. Then we get -½ and 0, ½ and 1. We add 3 to that. We get 2, 2½, 3, 3½, and 4. For our vertical stretch compression, we do exactly as it says. So this would be -2, -½ 0, -½ -2. Adding 0 doesn't change these values. And then we graph them. We graph our parent function, x and y, and our new vertical, or our new function, x and y. Let's see what we got here. This is x squared. Remember, this is a parabola. So this shape is like a U. It does not come to a point. The only one that we have that actually does kind of come to a point right now is absolute value. Okay, there's my parent function. There's my parent function. Now I need to graph my transformed function. I have 2, -2, 2, -2, 2½, -½ Then I have 3, 0, 3½, -½ and then I got this one down here. Looks like this one goes a little bit like this. There we go. There's my A of x. That's how we do those. For the next one, critical values here. My parent, well, let's do this. We have a reflection over the x. We have a vertical stretch. We have a reflection over the y-axis, horizontal compression. We have left 3. And we have up 1. And the function here, I see a cube and a root, or a 3 and a root. This is going to be a cube root of x. That's my parent function. And if I look at the critical values there, these are a little different. -8, -1, 0, 1, and 8. From there, I get -2, -1, 0, 1, and 2. If I put my vertical stretch, compression, reflection stuff, I'm multiplying by -2. Then I am adding 1. Let's go ahead and do that. 4, 2, 0, -2, -4. Add 1 to those, I get 5, 3, 1, -1, -3. Horizontal stuff, let's see. This is being multiplied by -2. I know I have to do the inverse, so I'm going to divide by -2. And horizontal, it says x plus 3. I have to do the inverse operation. I'm going to subtract 3 from everything. If I take and divide these things by 2, -8 divided by -2 is 4. Then I get ½ and 0 and negative half, and negative 4. Going to subtract 3 from all these things. I get 1, negative 2.5, negative 3, negative 3.5, and negative 7. And let's see what these things look like. Cube root, let's do our parent function here. 0, 0, 1, 1, 8, 2, 2, 6, 7, 8, 2. Looks a little something like this guy right here. And then the negative part, 7, 8, 2. Looks a little something like that guy right there. This is my parent function. If I step in here and graph my transform function, I have 1, 5. 1, 1, 2, 3, 4, 5. Then I have negative 2.5, 3. Negative 2.5, 3. Then I have negative 3, 1. 1. I have negative 3.5, negative 1. Negative 3.5, negative 1. Negative 3.5, negative 1. Then I have negative 7, negative 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. This guy looks a little something like this. And that is my B of X. You can check it using Desmos. I've talked to you about how to do that. Yeah, pretty cool. Pretty cool. Let's look at the next page. This is the 3 level, the next part for CFR3. Base quadratic, we're taking the description and rewriting a function from it. Base quadratic function means I'm doing x squared. So I'm going to put a something with squared in here. Let's see, do I have vertical stuff? Vertical stretch of 3 and reflection over x-axis. Got this in here. I do have a horizontal compression of 2. So 2 times x says left 6 units. So I'm going to put a x plus 6 in here. And then up 4. So vertical stretch of 3, reflection over x-axis, horizontal compression of 2, left 6, up 4. Fantastic. Absolute value function. I'm going to be working from something that looks like that. Let's see, do I have anything vertical? Okay, vertical compression of 1/3. Let's see in here, horizontal stretch of half. Ooh, and a reflection over y, so negative half, times x, and then this doesn't move left or right. So I didn't need the parentheses, but you could put them in there if you wanted to. And then down 5. I'm going to call these like g of x, because I can. Because I can. Right, these are 4-level examples from CFR4. CFR3 is going to make sure you understand the concepts of the descriptions. A couple examples here. Let's see. My parent function, if I've got negative 2, positive 4, negative 1, 1, this is x squared. I can tell that already. And I know that I do the exact thing I'm supposed to. So 4 to get to 12, 1 to 3 is multiplying by 3, then subtracting 1. Okay, got my stuff there. Here, let's see here. What am I dividing by? Dividing by, right? Because it's the inverse, what I'm trying to do. So I'm dividing by, looks like negative half. Dividing by negative half. Looks like I am dividing by negative half, which means I should have been multiplying by negative half. Remember, because it's the inverse. And then I'm adding 5, which means I would have minus 5 there. You could also think of this one as multiplying by negative 2, which means this one over here would be dividing by negative 2, which would make it, that's where the negative half would come in. So if I write this stuff in here, my new function, I've got 3 times, and I'm working in x squared here, negative half times x minus 5 squared minus 1, g of x, why not? This 4-level down here. The table for the function f of x is shown below. Create the table for the function g of x equals f of x plus 2. We know if it's just f of x plus 2, it just makes my Y values go up 2. The X values, again, this is a function. 2, 4, 2, 1, 4, 3, 6, 7, 8, 11 is a function. And if it just goes up 3, it doesn't change the X and Y. Just makes, I'm sorry, it doesn't change the X values. It just makes the Y values go up. So I would go up 3. This would become 4, 6, 10, and 14. There you go. There you go. All right, that's your last check. Hope all is well. We'll talk to you later.